starting out 8, 6. 8, 6 is vectors. And a vector is a quantity that has magnitude and direction. So magnitude just means a size or a length. So magnitude and direction. Component form is like this, x, y, and it's almost like an ordered pair. And the x is the horizontal change. And then the y is the vertical change. So it's, like I said, it's almost like an ordered pair. You go left to right first, and then up and down. The first example, we want to write this vector in component form. And component form is almost like an ordered pair, only it has the arrows on the end. So if we start out at H and we want to get to G, we go 3 spaces to the left. So that will be a -3. And then we go up 1, 2, 3, 4, 5. So component form will be -3, 5. It's just the notation that somebody way back then chose to use. This is the vector. It has magnitude and direction, and you do -3, 5, because you move 3 spaces to the left and up 5. Let's do letter C next. It's very similar. To get from here to here, you go 3 spaces to the left, 1, 2, 3. So it will be -3, because this is your starting point. And then you go down 5. 1, 2, 3, I'm sorry, you go down 4. So that will be -3, -4. From your first point to your second point. This one up here, we should have had the vector written MN. If you're given 2 points and you want to find the vector between them, you do the second y, subtract the first y, second x, subtract the first x. So we're going to do 2, subtract a -8. Second one, subtract the first one. And then -7, subtract 1. And when you do that, zip zap that, 10, zip zap that, -8. So your vector written in component form, and the component form means you have those arrows on the end, is right there. Yes?
So it's x2 minus x1 and y2 minus y1?
Yep.
So you start with the back one?
Yep. You start with the second one. Same thing here. Initial point is your first point. Terminal point is your second point. So we are going to do 6 minus a -1, 2 minus 1. And when you zip zap that, you have 7. 2 minus 1 is 1. So if you're trying to come up with the vector, yep, you subtract them. Second, subtract second. Second, subtract second. Adding the following vectors, you just add your x coordinates, add your y coordinates. 3 plus -7 is -4. 4 plus -1 is 3. This one, you're just adding them. They're not asking you to find the vector or anything. It's just asking you to add them. Letter B, -8 plus -7 is -15. Negative 2 plus negative 5 is negative 7. Letter C, 0 plus 2 is 2. 6 plus negative 6 is 0. So adding them, you just add your x's, add your y's. 7 plus negative 6 is 1. Negative 3 plus 9 is 6. Now the magnitude is the length of the vector. Another name for magnitude is length, or if you want to call it the size, how big it is, it's magnitude. And on the back here, we are asked to draw these on the coordinate plane and then find the magnitude. So first of all, we just start from 0, 0. We want to do negative 1, 5. So we go back 1 and then up 5. And then draw an arrow in there. And that's the vector negative 1, 5. Now if you want to find the length of that, you can draw this right triangle in. And I drew it in there in blue. This side is 1. This side is 5. So magnitude, you guys have done already. This is a Pythagorean theorem question. This is a right triangle, and you're asked to find the hypotenuse.
Do you have the 1 and the 5 on the same line?
Nope, this tells you left to right, so you go 1 to the left, and this tells you to go up 5.
Do they have to stay on
Does 5 stay on the
Yeah,
axis?
the...
Yep.
Okay.
I am. So, next one. Let's go, guys. Let's go. So, the Pythagorean theorem, if this length is 1 and this is 5, you can do c squared is 1 squared plus 5 squared. So that becomes c squared is 1 plus 25. Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. After I drew the vector, I drew this right triangle in here. We went 1 to the left, so that length is 1. And then we went up 5, so that length is 5. 1 squared plus 5 squared is 25. So we end up with c squared is 26. And c ends up being square root of 26. 5.09, 5.1. Okay? And some of you are going to get to the point when you do these where you can kind of use this formula. Just do the square root of x squared plus y squared, square root of this number squared plus this number squared, and then do the square root.
Oh, wait, how did you get 1 to be positive?
Because it's a length. If I had to go negative 1 to put it on my graph, but when I drew the triangle in, I just made it a positive 1 because you can't have a length that's a negative.
So the numbers are always going to be
Yep,
positive.
yep. And when you square them, whether it's a positive 1 or a negative 1, it will be positive anyways.
Okay.
Okay? Let's draw the next vector, negative 3. So we go 3 to the left and down 1. And we draw that arrow in.
Would that be up 1?
It would be up 1. Negative 3, up 1. And that's our vector. Sorry about that. We need to draw that right triangle in there. So this, we went 3 spaces to the left. So the length of that side is 3. We've gone up 1. So the length of that side is 1. So to find the magnitude, you can use the Pythagorean theorem. Or, like I said, some of you are going to get to the point where you can do 1 squared plus 3 squared. 1 and 3 are the lengths of the sides of that triangle. So that will be 1 plus 9, which is the square root of 10. And what is that as a decimal? 3.2. The direction is the angle that the vector makes with the horizontal line. The angle the vector makes with the horizontal line. So again, we're gonna draw the vector in over 1 and up 4. And I'm going to draw that right triangle in again. This side length is 1. That side length is 4. And we want to find the direction. Again, we have a right triangle here. We are trying to find this angle right here. And this again is something we did earlier in this chapter. This is the opposite side. This is the adjacent side. So to find the angle, we would do the tangent. Tangent is opposite over adjacent. So tangent of the angle equals 4 over 1. And if you have the numbers and you want to find the angle, you do inverse tangent. So you should be able to do inverse tangent of 4. 75.96. So this angle right here is 76 degrees. The next one, the force exerted by a tugboat, is given by the vector 7, 3. And this vector does go off your graph a little bit. Over here to the right, we have 1, 2, 3, 4, 5, 6, 7. And then you go up 3 spaces. So 7, 3. You can draw the right triangle in there. This side is 3, this side is 7. The direction is that angle right there. That's the angle we're trying to find. This is opposite and adjacent. So you will have inverse tangent of 3, 7, 3 over 7, which will give you your angle measure. And that angle would be roughly 23.2. Equal vectors and parallel vectors. Two vectors are equal if they have the same magnitude and the same direction. So we need the same magnitude and same direction. And parallel vectors, they either have the same direction or opposite direction. First example, equal vectors. They have to be going in the same direction and exactly the same size. There's only one pair of equal vectors in here, and that is RS and PQ. And technically, when you draw a vector, you should put that little arrow above it. Kind of looks like a ray. RS and PQ. If vectors are equal, they will also be parallel. So for parallel, we're going to have the same one, RS and PQ. And the second set of vectors, I'm going to outline them here in red, these actually go in the opposite direction. So those will be parallel. MN and XY would also be parallel. They're going in opposite directions. Second example, finding the equal vectors. Two that are the exact same direction, exact same size, will be right here, which is J, I think that's an I. Oops, and I wrote that wrong. IJ. The arrow needs to go above the J. And then the second one is OP. And then for parallel vectors, you will have that same one. And then your second set right here, these are also parallel. They're different sizes, they're different directions, but they are still parallel. So that will be KL and MN.